Gotcha. Nice. All right, welcome. Everybody's back from lunch. I guess I've been working Kercher Engineering and working with the AgileAssets software a little bit longer than Scott, 2 months. So try more like 8 years. So it's been a little while longer. So I condensed the topic here a little bit because I couldn't get it all on a slide. So you have best-in-class software. What about the data? I thought, let's just sound a little nicer too, I guess a quick question is, how many of you are pavement managers, pavement practitioners here in the audience? I know you are. There we go. Oh, yep. Oh, I guess all the usual suspects, right? How many are using visual survey to collect pavement data, pavement condition data? Okay, a few. How many are using automated or some variant of automated? Okay. How many of you have sort of struggled to transition from visual to automated? Okay. All right. Well, I suppose if you weren't struggling, you probably weren't doing it right. So I guess that's about what I expected. A little bit of background here. So as I said, we've been a partner with AgileAssets for a long time. It's been nearly 8 years, if not maybe a little more. And in that time, we've got to know a lot of you. And we've got to know how you manage your assets. We've got to know your business rules. What is the best approaches to make that happen? What I like about the relationships that I've built is that I'm learning from you and you're learning from me. So every time I get the opportunity to be in front of one of you all is really a special treat for me. So when you have the AgileAssets software, you have some of the most highly configurable and most powerful analytics on the market. I could say that with confidence. And not just because I'm at their users conference. And so I would say that what we've done the most with that relationship is we've really focused on you, the users. We've focused on simplicity to get the most benefit out of this software. But there's challenges, right? And so the topic that I'm going to talk about here is not necessarily implementation of the software challenges, but something else that seems to always follow these projects is what is your level of comfort with your data? And so I've highlighted 3 specific clients that we worked with over the past couple of years to transition them actually from some visual survey method that they're using, generally a sort of homegrown version of data collection, to an automated method. And so I'll sort of go through each at a time here. So we'll start with the state of Idaho. They've been implementing AgileAssets Pavement Analyst since 2011. Their rating process was a very simplistic process. It was essentially a sort of a 0 to 5 scale. 5 is the best and 0 is the worst. And it was truly just drive the roads at high speed, get to the end, give it a number, and move on. At the time, they were also looking for engineering configuration of that software. So they didn't at the time have the in-house staff to man that process. And they didn't have their decision trees and their performance models. They didn't have sort of a formalized treatment toolbox. So all of those improvement rules and things that we struggle with, right, to get up and running in the software wasn't there. There was no place we could really go for it. So we sort of had to run through that process with them and help them configure that software. We configured it around that 0 to 5 scale, even to my own sort of concern, because there's not obviously it's fairly coarse. There's not a lot of granularity there. We can't make a lot of very detailed decisions on something that broad. So we've always been trying to sort of work with them, push them to use a little more detailed process of collecting their data. It just so happens that in 2015, they were also looking to use their data collection, automated data collection van to start to collect DeStresses. Now, they had already had this van for years. They manage it themselves. They purchased this from the vendor, and then they essentially manage it themselves. And they've been collecting rutting and IRI, but they hadn't been collecting any DeStresses. So they wanted to implement that. So we helped them develop a data dictionary. What data are you going to collect? What DeStresses? How are you going to sort of define severity and your extent rules and so on, and then work with that vendor to make sure that they could sort of provide that level of detail. And so at the end of that whole process was, well, now that you're changing all these things with the data that you're actually collecting, the detail you're collecting, you actually need to go back and look at your your decision rules and all these other things in the software and sort of reconfigure those things as well to try to take advantage of this detail. And so that was a very successful project that wrapped up somewhere, I think, in November of 15. So they are now up and running with that van. They're using that to collect their data. They're calculating their own distress indices now and moving through that process. The state of New Mexico. They've been a long-time AgileAssets client. I'm not even sure on the initial date, but I think I asked Eric Peroni. He was thinking sometime in the 90s, so it's been a long time. In 2012, they were looking to develop out some of these sort of engineering framework components of the software so they could start making detailed decisions. Now, they also were using Visual Survey at the time in 2012, but they were using a little more detail. They were actually collecting DeStresses, severity, and extent. They were capturing them in sort of a matrix value, and they would determine from that what the scores would ultimately be in the software, so they could sort of calculate their sort of composite indices and so on. We configured around that, and that was a fairly robust configuration as well. Immediately after that, in 2013, they did a long-term contract with an automated data collection vendor who is now doing laser crack measurement system, the LCMS, to gather all their data. We didn't actually work with them to develop out the data dictionary, but we did help them reconfigure the software to take that data in. And so that process is actually completed now, and that vendor is continuing to bring in data into that software. I think we have 3 rounds of 13, 14, and 15, I think. So that data has sort of been it's imported, and all the indices have been calculated, and you're sort of running with that data. Again, this process is sort of, there's always going to be some level of calibration. You're going to have to get in there and make sure that the stresses that they're collecting can be captured, and that you feel comfortable with the results, because ultimately we're using that information to drive decision making. And then last but not least, I make that really small state look really big, right? I guess when it's behind Idaho and New Mexico, suddenly Delaware's Delaware's been another long-time AgileAssets customer, and I won't burden Rhonda with the years, because I know that's getting to be a little bit of a touchy subject, right? But a long-term client. They had performed visual survey, windshield survey, I guess I should say, since up until about 2008. And about that time, they transitioned to a sort of a semi-automated process. They hired a data collection vendor to go out and image this data and get all their data, and then they took that and sort of manually reviewed that data on the images. So they're using a van to do that. Now in 2015, they transitioned again to another new vendor. And in this project, they actually were able to put in a lot more detail, especially in really clearly identifying what their distressed data needs are. So building out a sort of data dictionary, and then going through the process we ultimately ended up going through the process of helping them reconfigure that software. And so we've had a lot of that sort of success going through this process and capturing that. We are currently ongoing work with Delaware in helping them calibrate their data collection vendor, and be interesting to see where a lot of that goes. Let's talk a little bit about how data flows through the AgileAssets software. And I was going to make a little bit of a joke, but Eric's not. I don't even see Eric Perone here, but unfortunately, I was going to make a joke on his behalf. If any of you have sat through Eric Perone's, meetings, you've probably seen this pretty old slide, and I still use it, and it sounds like maybe he does too. So I stole it from him, and I think it's, but it gets the point across, and that's the important thing. Let's talk a little bit about the process. And we start off with getting our condition data. We have a number of other attribute data that we're using to sort of make decisions in the software, whether it be sort of functional classification or some other rules, traffic levels, and so on, that we're feeding through it. From that, in general, we're going to be calculating some kind of condition index score. Sometimes it may be, and that can vary in detail. I've seen some agencies that are all the way down to the distress severity level. There's a specific index just for that. I've seen some that are a little not so detailed, so they'll go just to a rolled up sort of composite index. But at some point, you're driving that information off of a score that you're calculating, and then using that data to predict condition, right? So once you've sort of you've captured that score, you're predicting condition in the software, you're feeding the models to that. You're also feeding data to the decision trees. And so when we talk about, the main focus of a lot of this is how are we making sure that the data that we collect in the field ultimately aligns to treatments that we're recommending to fix those locations. This information is fed through the optimization analysis. You apply objectives and constraints, and you get some output. You get conditions and budgets. Ultimately, what you're really looking for here is to get some sort of valid work plan, right? I mean, one of the beauties of this software in particular is the work plan results that you could get give you a really good first pass of your project selections, or at least they should. And that's, I think, the key here, is that if they're not, there may be a breakdown somewhere in the process. My concern is that breakdown may be really early on in the process. And so we're driving all of this decision making off of condition data. And you can see how early in the process this thing resides. And if you sort of miss the opportunity here to make sure that this is accurate and you feel comfortable with it, if you don't have that level of comfort, then you're likely going to not feel very good about the results you're getting out of the software. Let's sort of go through a high-level overview of that sort of concept. So in the Agile software, you sort of have these sort of large engineering components, your decision trees, which are helping to identify where and when you'll do work, your performance models, how long these treatments are going to last. You're feeding those sort of using the optimization to help pick your projects, and those are getting your treatments and your costs and so on. So sort of big high-level stuff in the software. The process starts, though, way back when you're out there collecting this information on the road. And so you're going to be out there getting, different types of cracking, different distresses, whether it be, alligator cracking, transverse cracking, block cracking, weathering, raveling, whatever the case may be. All of these distresses are feeding into, in general, are feeding to calculating a score associated with those distresses and are rolling up to triggering the most appropriate treatment to address those distresses. And this may seem so intuitive that why did I bother to put it on a slide? Well, because in every instance, whether it was a state DOT or down to a local government level that we worked in, this has been the most critical part of that. Because ultimately what matters is the people who pick the projects. If you want them to adopt this software and adopt the results, they have to trust this. They have to trust that what they see when they go out there matches what came out of the software. And that's a tough thing to do. It can be a tough sell. I'm sure a lot of you who work in states that are fairly decentralized and your district engineers are picking those projects and not the central office who sort of manages this overall project. You're gonna find maybe a lot of sort of resistance to that. So how do you get them on the same pages as the software? Well, you ensure that this process doesn't break down. Let's talk a little bit about the data conversion process that we use. Again, from a fairly high level, there's a lot more detail that we could go into, but let's just kind of get through it. Your data collector vendor will go out and collect raw distress measurements. So when we say that, we're saying you've classified the distresses that you want to have them capture. I mean, they can capture, pretty much the whole book, but you capture the ones that are specific to maybe your state's needs. They're capturing, square footage, linear foot, counts, those sorts of things. Very sort of raw detail of these distresses. And so you sort of get, if you've ever seen these sort of LCMS, crack maps on the surface, you're going to get something like this, and they're going to return to you in the database. They're going to return a number. So you'll have, say, in some severity level of distress, 2,000 square feet or something, for an area of distress. The nice thing about using automated data is that they can capture every severity of every distress. And so whereas it was somewhat of a limitation in the visual survey process that you tend to try to create, you create some sort of dominant distress severity or some rule like that that you will base all of the decisions and calculations off of. This actually rolls up all of the distress severity levels, and that could be a big benefit. The next step is to convert those raw measurements to severity indices. And so for these agencies that we worked with, we actually have, for every distress, we'll have sort of some models associated with just the how the index relates to, say, the percent extent of that distress on the road. And so every severity level has its own model, and obviously these are the types of things that we would test and calibrate and configure to ensure that these scores ultimately come out to equal what you would expect if that percent extent was on the road. And so this is a very sort of a critical component of the process, is ensuring that these types of models are pretty accurate. You note here that the bottom on the x-axis is percent extent. And so ultimately what we're doing to sort of simplify this process and to make the data maybe a little bit easier to consume is we'll take those square footages, say, and we'll divide them by the total square foot of the captured area. And so when I say captured area, I don't mean the whole road area, because ultimately they're just looking at one lane or something like that. So it's ensuring that we can get, okay, that's some percentage of that area is that severity level for that distress. We then go and calculate each distress index. And so from those models, we would ultimately have an index for each severity, but then roll that up to the distress level. So let's use alligator cracking as our example again. I may have 3 severity levels of alligator cracking that have models, but I'm going to have a composite score, some kind of an equation or something that I use that rolls that up into some sort of general individual distress index. And then ultimately, I'm going to have some sort of maybe not decision making, maybe reporting level indices that I want to use, some composite indexes or some sort of network level indices. So going through that process, again, I sort of glossed through this a good amount, but has been a lot is a lot of effort to actually get it to that point. And so for agencies that maybe are struggling or having that issue, obviously you're not alone, and I think as the technology improves, and it's gotten to the point now where it's pretty good. I mean, we're starting to be able to use this data to drive decision making, and I think the things you would have heard maybe years ago about automated distress data collection maybe just don't hold true anymore, and it's certainly an opportunity. I'm going to use Delaware Project as a case study of how we sort of some of the sort of things that we dealt with, the issues that we dealt with as we went through this. So again, a little bit of background. They transitioned from the windshield to automated over time. Like I said, it wasn't a kind of clean break. They were doing visual up until a certain year, and then over the course of years, they had sort of varying vendors who were providing data. But ultimately, to the very recent time, up till last year, they have really solidified that process, and now are capturing distresses that they can hopefully use to drive those decisions. They also recently reconfigured the AgileAssets software for that process, and that was part of the work that we actually helped them do. When we started doing our analysis testing, so different than, say, what AgileAssets will do to ensure that the software works, the window's open, and those sort of things, we're talking about more sort of on an engineering testing side, where we're now going in and ensuring that if I expected this treatment to come out with this result, we're going to make sure that that happens. How do we ensure that? And so as we started to kind of go through that, we started noticing some inconsistencies with the treatment's results compared to the field. And specifically to the field, what I remember, I got an email or a phone call from Rhonda and said, you need to go look here's 3 locations, and they are just completely off from what we would expect. The scores that are coming back, way off from what we see when we look at these on the images, or if we go out and visit these sites. And I said, okay, well, let's figure out why. So we went out and did some sort of detailed field measurements. We went out and literally went out and measured the cracks essentially, and determined that yes, there is something that is off about the calibration of the data that's coming in. We couldn't really necessarily put our finger on it, and since we were sort of an outsider to that vendor's project, we just would have the ability to talk to them. We were just kind of keeping up and letting them know what we were finding. But it wasn't until very recently we actually created a more sort of detailed review approach to make sure that we can get this all calibrated. And so by calibration, that could take on a number of different things. It could be calibrating the way the vendor sort of sees or sort of images this data. You know, the LCMS has got some things that you can tweak here and there. But also, we may have to tweak some of the business rules that you followed all these years. We may have to change some of the DeStresses that you collect. They may not be relevant. Or maybe there's so much limitation here that be concerned about trying to make decisions off of that data. So here's a couple quick examples. We had a section of road that Rhonda had sent to me, and she said this road is in pretty bad shape. I had a downward image of that location from the van, and we had it showed some cracking. It showed there's obviously this sort of dark area here. So we're not too sure about what that was. We went out, and so we found that if we go out, it was about 4% of the area had medium severity fatigue cracking or alligator cracking. And the index was coming back in the software as a 95, so it's like really high. In other words, saying this road is in very, very good shape. We went out to the site and physically measured this data and came up with more like 7% of medium and 9% of high. And that was just in some certain areas that we were looking at. We're trying to ensure we maintain the same location that the van had driven. And although that there's going to be some little bits of differences here and there, we felt like we got it pretty close for that. So the index was a 78. Now I give you a little picture. I just overlay that same image with that picture. And so, right there was a pothole, right? So it showed up. But look at all the other all the other cracking that was there and was missed by the process. So we talked to the vendor. We tried to get some ideas of how could we have been so far off? Where's the breakdown in the process? And we're working through that now. And so unfortunately, I don't have all the answers for that, but they did give us some insights into that. But the important thing is that once DelDOT identified this issue and they asked us to go out and review them, we immediately raised a red flag about be careful using the results in the software until we've got this hammered down. And so I sort of, maybe it's a challenge to everyone that's out there and using this data is how often are you actually reviewing this process? And are you ensuring that the data that comes in is driving and meeting your need for treatment selection? Another critical one was Raveling. And so in past years, DelDOT managed a distress called surface defects, which is sort of a conglomerate of like oxidation and weathering and raveling and so on. And so when you're doing windshield survey, it's easy for someone to say, I've got, the whole road is 100% of the area is oxidized or is whatever. But what we found was that when we talked to the vendor that obviously if anyone's familiar with this, it is one of the tougher distresses to collect. And so relying on the technology that exists today to get that same distress they were using in the past was going to be tough. So we looked for alternatives. So we had them look at Raveling, which was something they could specifically capture. But what we found was in some locations, they were missing it essentially completely. And this was one example. I hope not to set this up be too hard on this, but they'd got 0% measurement, so they had a score of 100. So it was a perfect location. It's maybe a little hard to see from this image, but and I should have grabbed the other image that had the curb line with all the stones sitting on it. This was essentially a 100% raveled surface, and they had to the point where it was rutting in the wheel paths because of the raveling. And so we went back and asked, where is sort of the breakdown in that process? Because the process that was there before chose do nothing for this location, but by Delaware's business rules, if they have 100% of high severity raveling, they would want to mill and overlay it. They'd want to actually replace the surface. And so we needed to be sure that to find out exactly where that breakdown was. Now again, because we're sort of in the middle of this, we're going to be looking into more detail and figuring out how we can solve some of these problems. And again, it may be a function of we might just have to change our bar, change where we thought we were going to do decision making to somewhere where the technology is aligned to that. Unclassified distresses. So again, not every state is going to track every distress. So you're going to track the ones that either you feel are most applicable to you, or maybe are sort of a historical process. You've always tracked those going back to your windshield days, where you wanted to make sure you didn't overburden your survey crews with 10, 12 distresses every time they go out to look at the road. You give them 5 or 6 good ones, that will get the point across. Well, again, as the technology's improved, with this process, not only are you able to get sort of, every severity level for distresses, you can essentially get them to report any distress. I mean, as long as you feed them the rules, they will go and capture those distresses and classify them properly. What we found was, in some of these locations that were coming back with these sort of favorable scores where they weren't triggering any treatments, was that in some cases they just weren't tracking any of these distresses. And so this example had, for surface treated roads, they weren't specifically tracking pothole issues, or in this one down here, or sort of block cracking or environmental cracking. And so when you step back and look at the whole road, you see all of this distress. And yes, your first instinct is, we need to rehab this location. You look at the results of the data collection effort, and it's saying to maybe do some minor maintenance or do nothing. That was a big flag for us. And so where are the breakdowns in that process? Distress type confusion. A classic one I put up here is a bit of a question: is that a combination of fatigue or longitudinal plus transverse cracking, or am I looking at block cracking? And so there's sort of some very specific protocol for that, and so on. But again, going back to the way it was done with the windshield survey and trying to transition to this automated method did not translate well. There was some issues in identifying what are we actually looking at. Why is this important? Well, in most cases for driving to treatment selections in the software, you're going to want to target treatments to your structural type distresses for one type of treatment, and your functional or environmental or non-load type distresses for another type of treatment. And so I sat in with Magdi's presentation yesterday. They have the similar process where they have multiple trees arriving at multiple treatments in the software, and it's the highest priority one that's sort of coming out as the result for that location. Well, it's the exact same thing for this. If the treatment identification is not done properly, I've got a combination here of potentially structural distresses intermingling with environmental distresses, and I need to figure out which one is the right one. What did they actually capture, and is that going to drive me to the right treatment? Single lane direction data collection. We're never going to get over this one, I think. It's just because it's extremely time consuming and costly to have them do every lane for every road. But when the vendor is essentially looking at one side of the road when they drive it, you miss a whole lot of other things that are going on. And so you have to be wary of that. You just have to know that when you're looking at the data in the software and it's driving to a treatment, that treatment actually aligns to what's actually out there on that road. So as long as everybody realizes that limitation, everybody will be fine. But just realize that depending on which direction they traveled, you may get different results. And so obviously, like they're sort of not seeing anything over here. Now, if I go out there and do visual survey or the windshield survey, more than likely you're sort of scanning careful now. You're sort of scanning the whole pavement area. And so you would pick up things like this sort of large pothole over here, or the edge cracking, or the whatever else is going on that side of the road also. At least you're going to try to. And hopefully that would have been getting you to the treatments that you would have expected. So now there may be an opportunity for a breakdown in that process. So what's next? I've gone through a whole bunch of issues that we've seen in standing this up. We went through the whole process of getting the software configured. We are running optimizations. We're getting results. We're trying to feed those to the work plan. We're trying to get those out to the districts, but we're now very concerned to make sure we all can agree that we're getting the data we expect and it's going to get us to the right treatment. And so we are working with their current vendor to get to that point. And I will say that if you're ultimately in this situation, or you think you may need to go and start talking to your vendor, they're absolutely willing to work with you. They want you to give them the detail. In fact, one of the biggest limitations that we found is that your data dictionary may very well not have enough detail for them to go and get what you want. And so you need to be very careful to work with them closely to make sure you're getting that. Once we sort of work through those calibration, that calibration effort, we are looking to make whatever changes may need to be made in the software. My guess is right out of the gate, we're going to have to include all the other DeStresses that are on the location, because we can. We can do that. And those will now become part of the decision-making indices and will trigger treatments maybe a little closer to what we would expect. And then we're going to want to go through a process of calibrating that analysis. We're going to want to make sure that, now that we're getting this data, this is likely going to be a sort of an iterative process. We're calculating these scores. We're getting those treatment selections. Let's go back and ensure that we're on the same page. Do we have to adjust anything? And then obviously a big thing is educate your stakeholders on those expectations. Again, it's very likely that the person at the very top of the organization who sees the scores that you report to them every year and the number of lane miles you need to treat and all those things have no idea that the data that drove all of that was done on one lane. And that's just one example. And so make sure they understand that and that there's a possible limitation there. Especially if it's they're driving to work every day, they see that same road that's in horrible shape and they're thinking, why aren't you getting out there and doing something with it? It's like, well, if I look at the distress data, that one lane is not bad. The rest may be pretty bad. Or you're driving in the opposite direction of the vendor. So some final thoughts here. So insist on field verified data calibration. So, I can't stress that enough. Always make sure that you own this process. And so even though you're going to have a data vendor who is going to be looking out for your best have the best intentions to get you the right data, you really need to own it. You need to own your data dictionary. You need to own the limitations as well. And over time, this technology is growing so fast, and they're getting so much better identifying and classifying distresses. More than likely, you're just going to sort of evolve with that and get better as well. Develop a good data quality management plan. Obviously, you're getting the data in, but then what is your process to ensure that the data that's coming in is going to be sort of clean enough and ready for decision making. Be prepared to adjust the software configuration. Again, I've noticed there's a lot of sort of hesitation from agencies to move away from their windshield survey data and go to automated because, well, we're going to lose all of this history. Well, that could very well be the case. Depending on how simplified that process was and what you can do today to get good decisions, you very well may lose years of data. But the question really comes is, you're going to ultimately start sometime. I mean, you might as well start now, and it's sort of like a Band-Aid, right? You just got to rip it off. And there's quite possibly there's some research efforts that can be put in to see, can we correlate this data in some way? You may not use it for anything any real heavy lifting in the software, but maybe it's a way to sort of validate things across the years and across the history of your data. Again, be aware of the benefits and the limitations of the process. I imagine as long as you're educated on that process, then the results coming out of the AgileAssets software are going to be as good as they can be. And then, I'm talking about some pavement projects that I worked on here, but this truly affects all assets. And so any of the other folks in here who are not pavement practitioners, but you're using the other modules in the software, and it's data-driven decision-making, all the same kind of thing. Classic one would be, for instance, signs. They're collecting the signs on the side of the road. They may. I remember being in a vendor display where you just truly couldn't get to see all the signs, maybe for physical reasons or otherwise. But knowing that those sort of limitations and all of that for every asset is also very important. And so, with that, thank you.
If anyone has any questions, I will try to find a microphone to bring it out to you guys. Okay, I'll grab the mic. Is there any questions out there? Come on, guys, it's about data. Everybody's got data. Let's go. I can tell you that in Louisiana, we switched. We had an opportunity to go to automated crack detection for our trucks back in the late 2000, maybe 2007, 2008, and at that time the accuracy with which you could detect the cracking and the different distresses was not that good. So we did wait on that, and within the last couple of years we have switched over. I say we, but they have switched over in Louisiana to automated crack detection. It's a lot better than it used to be. It does pick up quite accurate data, so it's a good option for anyone who's doing that level of survey on their roads. Let me go get the mic real quick. Oh, any questions? Oh.
My question is kind of when the state agency switched from visual or windshield survey to automated, I'm sure this affected the scores or the performance measures that are being reported to kind of the executives or commissioners or legislator. How did you handle this, or how did you address this?
Yeah, that's a very good point. It does, and so all these years of the data that's been feeding into, say, their overall condition scores and so on, the stuff that sort of gets reported out to the higher level, they change, because in the past, most of these agencies either, take that Idaho example, they had a 1 to 5 score, so they just averaged across the network 1 to 5, and they knew that they were a 3.5 kind of a thing. Once they started collecting severities and extents, and they were getting all the severity levels, and they were rolling them up into index scores, their network scores actually dropped. Their anticipated level of distress, or the current condition of the network, was lower than they thought. And so how do you handle it? I would say have ready to go presentations, meetings with those administrators, and show them why these things are changing, and do it before you publish any of the data. Because one of the things that's really been a tough thing is you want to get out there and you want to show off all these new tools and all this great stuff that's sort of feeding this process, but you kind of have to be kind of careful to roll it out slowly and ensure that you've got all the buy-in, everybody understands what they're going to be seeing, so that you don't go from needing $2 billion of backlog in your network to $4 billion, and everybody's wondering why, kind of a thing. You can prove why. And the idea would be to say, I've got all of this background data. So you might have to essentially develop a presentation of that. That's my guess. I mean, that's what I was hoping and recommending for a lot of these other agencies. Go and educate those folks on what they're getting now.
Our problem was every year it got better. Our data came back better.
Yeah.
That's those self-healing roads, right?
Yeah, absolutely. You love that. Yep.
So it was hard to say we needed money when our network says it's 95% good. It's not. We know it's not, but the number said it was. And we went through several vendors, and every time it got better. And so we'd have to explain or try to figure out why.
Yeah.
And now we're
And
for real this time. We're going to get it. It's going to be really accurate. And
yeah. Some of these images sort of tell that tale. If you think about that one example where it had 4% fatigue cracking, and then we came back out there and it was something like 15 or whatever percent. I mean, that seems like a minor amount. Well, on an index scale, that could be pretty significant. And so, it's when the results come back and they're looking like all these are really good, there's something in there we need to have calibrated. Is there a mismatch in the data that you want and the data that the vendor provides? Is there something in the imagery, in the actual crack detection itself that could be maybe causing issues and actually identifying? In fact, that was one of the things that the vendor actually recommended, was that because of the sort of the very coarse texture of this surface, that it's fairly difficult to actually get down in there and see those cracks. And so, but they had some control over that, right? They could actually control sort of the sensitivity of that. And the idea would be is to try to get them calibrated to that. Yeah.
Yeah, well, in this time we had the data dictionary, we had all this new changes in our system and the percentage of distress, and we really thought, okay, it's going to go down, and we'd warned everybody, and it went up again. So it's like, I don't know.
Yeah, but we did.
And
We
they say,
did.
so you guys don't need as much money, right?
Magdi's got a question again. Just a quick thing while we're sort of in transit here is we did have to do some work to the index calculations themselves also to try to realign them. So there's been some work to that to try to sort of temper that problem a little bit so no one no one gets concerned about this major jump. We try to sort of put it on a scale that sort of makes sense with the level of detail of data you're getting.
How was the automated data verified? I mean, like, did someone go out on the field and rate random sections, or did someone manually rated the images?
So the vendor's actually using the LCMS, they're actually detecting and then storing that data. But as far as field verification, that's sort of that's really where all this was headed. Once Rhonda had identified that we've got some issues. I mean, I'm out here looking at roads, and they're in horrible shape, and the software says that these are 90s or 95s, really good roads. They said, okay, well, let's go look at them. And then what ultimately went next was we went out there and physically measured out these DeStresses. So again, our validation in itself could be a little off here and there, but truly, like that one picture I showed of the alligator cracking, I could essentially took a wheel out there, and I wheeled off the areas of each distress level and then calculated out the scores to find the differences between the two. I mean, is it the most scientific thing in the world? No, but it's a validation, and at least showed that we have some work to do to get them a little closer.
So the validation was kind of in the field.
Yeah.
You went
Yes.
and re-rated the sections that were questionable.
That's correct, and it's ongoing actually. In fact, next week I think we have where I have to get right back onto the project. So we have some additional. We're up to about 30 test sections right now. The network obviously is a lot smaller. We can get to them in Delaware, not so much like in Texas. I imagine it's a lot of travel, but we took 30 test sections of the 4 pavement types that they use. So just a handful, and we got varying levels of distress. Tried to cross them over on the different functional classifications and those sort of things as well. And we're just out there, we're imaging these locations. We've taken physical measurements of about half of them, and we're going to take physical measurements of the other half of those 30 over the course of the next month and a half or something like that. And then ultimately what this is going to turn into is an iterative calibration process of the vendor working right with them. Like, let's just go through all of this and figure out what we can do. What ultimately might end up coming out of it is we've got to look into our index models and so on and actually adjust some of them as well. So the calibration is sort of software side and vendor side.
Okay, thank you.
Yep.
Got time for one more? Does anybody have a question? Okay.
Talk to what we do in Virginia. In Virginia, we have a number of calibration sections established,
Yep.
and before they start driving the state, each truck has to drive each section 14 times, and then we take a look at the results and make sure that they're consistent and accurate before we let the trucks go anywhere else. And they go through that process again each month once they start the collection to make sure that it remains consistent.
And that's exactly what we're trying to do here, I think, is start to develop control sections, like essentially control strips. They have to go and re-rate and calibrate and make sure that all of these things meet all of the criteria you've laid out in your data quality management plan.
The other thing I want to speak to is making the jump from manual to automated. What Virginia did is, in addition to publishing the new results, the automated data collection, they took some of that automated data and reformatted it into the old indices so that people could compare them.
Yeah.
And we still have district engineers that just use the windshield data, which we create from ACP summary, but which is in the old format, so they can still understand it.
Exactly, right. And at the district level, that tends to be the case, is they're comfortable with the old process, and that's how they pick their roads. And the idea would be is hopefully you've got them to buy into a lot of this to the point where they're comfortable with this new process of data collection. Yeah.
Just want to thank Aaron for his time in the presentation, and on behalf of AgileAssets, a speaker gift. Thank you so much.